Okay, so today we're going to build upon what we talked about with ratio tables, and we're going to learn how to compare two or more ratios, okay, in ratio tables. And your goal when comparing ratio tables is to find a common term in each ratio. Okay, so for example, let's say that Miss Doan has like 5 dogs and 6 cats. Okay, but let's say that Miss Lakin has 6 cats, but she has 8 dogs. And we want to know who has more dogs. We need to know like a common term in order to compare that, or to compare ratios, if that makes sense. So we need to both have 6 cats in order to know like who would have more dogs than the other person. Okay, so now we can compare that 8 is more than 5, so I would have more dogs than Miss Stone. We'll get through some more examples where that'll make more sense, but that's just a quick example. So our first step when we are comparing ratio tables is to read and understand the problem. What is the question asking? What are we looking for? While we're filling out these steps, we're going to go down and do example number 1. Okay, so using the tables below, determine which paint is more red. So if we're thinking about paint, so we're mixing together blue and red paint, and we want a paint that is more red. So what color do we want more of? Would be red. What color do we want less of? Well, if we want it to be more red, we want less blue. Okay, and this is basically what we would do in our minds after reading the problem, okay, to understand what the question is asking for. That's kind of what we're talking about there. Step number 2 is to create ratio tables if they aren't already provided. In this example, they are given to you, but we are going to do some examples today where we are going to have to make our own ratio tables. Okay, so next we'd create the ratio tables if they aren't provided. We're going to look in the first column or row, columns if they're up and down, rows if they're going like left to right, to try to find a common term. Okay, so for example, let's look in Toby's pints of blue and Joel's pints of blue. So we're looking in both of their first columns to try to find the same number. So this one's 3, 5, 6, 10, 9, 15. Oh, 15. And notice how they're not in the same spot. That's okay. But notice how here we have a 15 and here we have a 15. Okay. So what this means is that there's 15 pints of blue for Toby. When there's 15 pints of blue, there's 20 pints of red. Okay. What this means for Joel is when there's 15 pints of blue, there's 21 pints of red. So now we're going to think back to what the problem was asking. They want to know which paint is more red. Well, they both have 15 pints of blue, so their amount of blue is the same. But when they have the same amount of blue, Toby only has 20 and Joel has 21. So Joel's paint is more red. And when it says to explain in math, I always want you to use numbers. So Joel's paint is more red. That's not explaining anything. Explain why. So Joel's paint is more red because he has 21 pints of red. And Toby only has 20 pints of red. Joel's is more red. Okay, using numbers from our table in order to explain. Okay, that was pretty easy because we had a number that was the same in the first column. But let's like pretend like we didn't have that. Okay, so let's say that there wasn't a number, and you don't have to go through and erase this. I'm just going to erase it so it's nice and clean for us to look at. Let's say that there wasn't the same number. Let's say that this number was like an 18. Okay, so we have 3, 6, 9, 15, 5, 10, 18, 20. None of those are the same. Okay, so then I would go to step number 4, and I would look to the second column. or row of each ratio table to trying to find a common term. Okay, so for this example down here, we would look to the pints of red and the pints of red over here. So we've got a 4, no 4, 8, no 8, 12, no 12, 20, no 21, no 28. So there's nothing common in those rows. If there was a number that was the same, again, we could compare because we want less blue. So like, for example, let's say that there was 4 pints of bread, and we could compare these 4 to these 4. In Toby's, there would be less blue than in Joel's. So that would mean Toby's would be a more red color because he's got less blue in it. Okay, but we have to have that common number in order to compare. But in this example, we wouldn't have a second one, let's say in the first column or the second column. Then that's when it gets tricky. Okay, so again, I'm going to erase this just to give you a clean thing to look at. Okay, so let's say if you can't, let's go back up to step 5. So if you can't find a common term in either of those columns, we have to create one. Okay, and this is where we have to get a little creative. So like I've got 3, 6, 9, and let's pretend like this one's not here. Okay, I've got 3, 6, and 9. Over here I've got 5, 10, 15, and 20. I have to look at these numbers and see if I can get them to, by multiplying, to equal any of these. I would probably want to look at my smallest number because that's probably the most opportunity that I have. So can I multiply 3 by something to get 5? No. Can I multiply 3 by something to get 10? No. Can I multiply 3 by something to get 15? Yes, I can. So I can make a new entry, and if this were the case, there would be empty spaces down here. By multiplying 3 by 5, I could get 15. So I could get that common term. Remember, whatever I do to one number in the ratio, I have to do to the other number. So that would get me 15 blue, 20 red. Okay, so if you don't have a common term, you need to create one. And we'll do more examples of that. All right, let's just keep practicing. We've got 2 more examples to go through, and hopefully by the end of this, it'll make a little bit more sense. If at any time you're feeling like you're catching on, please pause the video, work ahead, use the video to check. Haley's making frosting by combining butter and sugar. She has 2 possible recipes. Recipe A calls for 2 tablespoons of butter for every 6 tablespoons of sugar. Recipe B calls for 3 tablespoons of butter for every 8 tablespoons of sugar. Okay. I'm going to skip over this question right now, and I'm just going to start setting up my table so far because I know that if I just read too much information, my mind's going to get lost. So I need a label for each ratio table. You could put recipe A, you could just put A and B, however you want to do that. I'm going to make them vertical today. Yesterday we did them all horizontal, or with our ratio tables we did them horizontal, so I'm going to show you what they look like vertical. And then we need to label each ratio table, but then we also need to label butter and sugar. You can write it out. You could just put the first letter, up to you. So for recipe A, it's 2 tablespoons of butter for 6 tablespoons of sugar. 2 tablespoons of butter, 6 tablespoons of sugar, recipe A. Recipe B says 3 tablespoons of butter, 8 tablespoons of sugar. Okay, now that we have our ratio tables set up, we want to go back and read the rest of this information. If she uses 48 tablespoons of sugar, how much butter will she need for each recipe? We need 48 tablespoons of sugar. So we need to get our table down to 48 on the sugar side. 48 tablespoons of sugar. So the first thing I'm going to do is think to myself, can I get 6 to go directly to 48? And you can use the multiplication chart to find this out. Because remember, we'd have to multiply. 6 times 8 will get us to 48. Whatever we multiply one number by, we multiply the other number by. 2 times 8 will be 16. Okay. Recipe B, again, we want to get it to 48 tablespoons of sugar. Can I go from 8 to 48? Yes, I can. If you're not sure, you can always use a multiplication chart to help you out. Follow that A row along until you see a 48. If you don't see a 48, then we can't get it there, and that's when we'd have to add another something in between. So we're going from 8 to 48 by multiplying by 6. Same thing over here. 3 times 6, 18. Okay, so recipe B will need 18 sticks of butter for 48 cups of sugar. Sorry, tablespoons of butter. Recipe B will need 16 tablespoons of butter, 48 tablespoons of sugar. If Haley only has 17 tablespoons of butter, which recipe should she use? Well, if she only has 17 tablespoons, which recipe would she be able to use? Think about that for a minute. Well, since recipe B needs 18 tablespoons, that would be too many. So we would need to use recipe A. And this is where those ratios could be really helpful in real life. If you are looking at the amount of ingredients you have and you have 2 different recipes to choose from, that could help you decide which recipe to use, depending on what you have for your ingredients. Recipe A, because you only need 16. All right, last one. Eli sells pizzas, 16 pizzas every 2 hours. Max sells 20 pizzas every 3 hours. Who will sell the most pizzas in 12 hours? Create 2 ratio tables to solve. All right, so we need a ratio table for Eli. We need a ratio table for Max. All right, we need pizzas in hours. Pizzas in hours. Eli sells 16 pizzas every 2 hours. Max sells 20 pizzas every 3 hours. We want to know who sells the most pizzas in 12 hours. So we look to the hours. We want to make that 2 into a 12. We can do that. 2 can go to 12 times 6. 16 times 6. Stack that up. You should get 96. All right, if you're feeling confident, I want you to pause the video, try Max's on your own. All right, again, Max will need to go to 12 hours, so we are going from 3 to 12, which should be multiplied by 4. 20 times 4, 2 times 4 is 8. Add another 0, 80. So who sells the most pizzas in 12 hours? Well, that would be Eli, because he sells 96. Max only sells 80. Eli sells 96 and Max only sells 80. Eli sells more pizza. Make sure in that explanation we just have numbers from our table. That is how we explain things in math, is by using those numbers. All right, that is it for today.